Yes, very good morning to all. My name is Chiranjeevi. So today I want to explain you about the what is meant by basics electric field followed by the Kirchhoff current law and Kirchhoff voltage law. See, as you know, we know that the material is consisting of different types of molecules. Okay, and the each molecule consisting of atom. So, there are so many structures which are proposed for the atom, okay, out of the proposed structures, the Niels Bohr structure is the more famous. So, according to that structure, according to the Niels Bohr structure, the atom is consisting of a nucleus as well as electrons. Okay, the nucleus is consisting of protons as well as neutrons, which are stationary inside the nucleus, and electrons are revolving around the nucleus in different orbits. Okay, so if you observe this particular structure, so here at the center, the nucleus will be there. In the nucleus, both neutrons are present as well as protons are present. And coming to the electrons, electrons are revolving around this nucleus in different shells in a different orbits. So now what happens? Why we need to study about this atom? Because electric field is associated with the charges. So how to get the charges? The charges are to be liberated or to be obtained from the atomic structure only. Okay, so now, if we consider uh, these are the basic statistics, the electron is having a mass of 9.1 into 10 power minus 31 kg, and a charge is minus 1.602 into 10 power minus 19 coulombs. The proton charge is equal to the electron charge but opposite in nature, and the proton is about 1837 times that mass of electron. So it will be about 1.6 into 10 power minus 27 kg. And here neutron almost equal to the mass of the proton, that is having no charge. That is charge of the neutron is 0. See, this is the atomic structure, that is material. If we consider any material, for example, sodium chloride, the crystal of sodium chloride is a tightly bonded particles of sodium as well as chloride like this. Similarly, water molecules are like this. Hydrated sodium ion NaOH will be like this, and hydrated chloride will be like this. This is the material which is consisting of atoms will be solid, will be bonded together. All the atoms are bonded together by means of various type of bonding techniques inside the atom. So this represents the solid state. Now, if we give some type of energy to that particular material or atom, which is shown in the previous slide, this one, if we apply some type of energy, then automatically what happens is the electrons which are present in the outermost orbit will get liberated. That is, the electrons may gain sufficient energy to get out of their orbits. So, how much is the energy that is needed to uh, release one particular electron? That is known as a ionization energy. So, basically, the ionization is the process by which an atom or molecule gains or loses an electron, resulting in the formation of ions. The resulting ion can be positively charged, that is known as a cation, or negatively charged, that is known as a anion, depending on whether the atom or molecule gained or lost an electron. Okay, so here this is the animation which shows you whenever the electron is whenever the atom is hit by some amount of energy, then electron which is present in the outermost orbit will get liberated. Okay, so this is also whenever a light energy is falling on the particular material, so the energy that is contained in the light particles in the form of a quantum. that will be sufficient to liberate the electrons from the material. Okay. Here in the particular animation, it is shown that potassium is taken. For the potassium, so 2 electron volts energy is needed to eject 1 electron. That is ionization energy is the 2 electron volts. Now, whenever the electrons are separated in that way, whenever the electrons they are very free to flow in their whatever the path present in the atom or atomic structure. So whenever the electrons are flowing, we call that as a current is set to flow. So the current is defined as the rate of flow of charge or the amount of charge that is flowing through a medium per unit time. That is known as a current. The conventional current direction is always to be taken opposite to the movement of electrons. That is flow of electronic direction. Okay. So if the electrons are flowing from left to right, we need to take the current direction as from right to left. Now, this when the current will be flowing, the current is flowing whenever there exists a potential difference. Whenever there exists a potential difference. If we consider the simple battery like a WSIS battery which is used in the wall clocks, etc., so it is consisting of two terminals. One is a negative terminal, another one is a positive terminal. So whenever this negative terminal and positive terminal are just joined by means of a particular load or some resistance, then the current will be flowing from this positive terminal to the negative terminal. That means the electrons are flowing from negative terminal to the positive terminal outside like this. Okay. So now once we had seen about the current, the next is we need to consider about the electric flux lines. See, obviously from the previous slides, whenever the ionization is there, then we can have two types of particles. One is a negative particle of electron, another one is the positive ions. So these two negative particle and a positive ion is exhibiting the charges property, that is positive charge and negative charge. Whenever there are two types of these charges, the charges are always associated with electric flux lines. The property of electric flux lines is they are originating from the positive charge, and if the negative charges are present, they will terminate on the negative charge. If negative charges are not present, whatever the electric flux lines originated from the positive charges, they may go into the infinity in this manner. Okay. So here, if it is a positive charge, if it is a negative charge, the electron electron that is electric flux lines will be originating from the positive charge and terminate on the negative charge. The direction of the electric field is also given by the direction of this electric flux lines. Okay. So here electric field is actually the effect of this electric flux lines will be limited to certain amount of region. Okay. Certain amount of region. See, for example, if this is a positive charge, so up to a particular region only its effect will be there, like this. Okay. So beyond that one, its influence will not be there. For example, if you take some point here, okay, so at that point there will be no effect of this particular positive charge on this point A. So here the influence of the electric flux lines will be limited to a certain amount of region only. So in that region only, the other charges may experience the force. So the electric field is can be defined as a region in which another charges may get influenced or will experience the force. That is known as a electric field region. Okay. Now, see, let us see this one. Here, this is the description of electric field. The electric fields are visualized using lines of force indicating the field's intensity and direction. In electromagnetism, electric fields are associated with the flow of electric charge. Understanding electric field is essential for explaining electrical interactions and is foundational in various scientific and technological applications. Okay. Next, whenever the two charges are existing, that is charge 1 Q1 and charge 2 Q2, then if they are separated by a small amount of distance, then there will be some force existing in between them. That force is known as a Coulomb force. The Coulomb force of attraction or repulsion will be defined as the force is directly proportional to the product of the two charges and is inversely proportional to the square of the distance separated by the distance, square of the distance. Okay, so if we remove that proportionality constant, then we can have a force equation, that is Coulomb force is given by F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. So that is the force equation. Now, this force might be either a repulsive force or might be an attractive force. It might be a repulsive force or might be an attractive force. So whenever the two charges are like charges, then the force is repulsive in nature. Okay. Whenever the two charges are opposite in nature, that is unlike charges, then there will be an attractive force between the two charges. Here Q1 is first charge, Q2 is second charge, R is the distance between the two charges, and epsilon naught is the permittivity of the free space. The permittivity is the property of the space or material, that is how much easily the electric flux lines can able to penetrate through it. So the value of permittivity is 8.85 into 10 power minus 12 farad per meter for free space. Okay. So next, coming to the electric field intensity, we had already seen what is electric field. Electric field is the region around a charged particles or objects in which another charges may influence or might be getting influenced the force. But electric field intensity is the amount of the force that is acting on a particular charge placed at a point inside the electric field. For example, if we are taking one electric field in this manner, that is due to the charge capital Q. Okay, so at a particular point, if you place another one more charge, if a particular point A, if you place a charge small q, then how much amount of the force is acting on this particular charge at this point? That is nothing but electric field intensity at that point. The electric field intensity units are Newton per Coulomb. Okay, so as seen in the figure. Next, electric potential. See, for example, consider an electric field region that is due to a particular charge, a base charge. Okay, so let us assume that a unit positive charge is at infinity. Okay, so we are having one unit positive charge at infinity. Now, if we want to move this unit positive charge from the point infinity to the point B, which is having a certain distance from the original charge, then according to the polarities of these charges, some work is to be done. Some work is to be done. That work that is done in moving this unit positive charge from infinity to a certain point in the electric field is known as a electric potential at the point B. This electric potential at point B. See, electric potential is defined as the work done per unit of charge as the charge moves through a field. V is equal to work per charge, that is W by Q. So what is the obviously the electric potential units are joule per coulomb. or simply we can call that as a potential difference, which is measured in the volts. So now I want to show you a small animation which will explain better the what is Coulomb's law, what is the
Electric
electric
field
field.
is a region around a charged particle or object within which a force would be exerted on other charged particle or objects. An electric field surrounds an electric charge and exerts force or other charges in the field, attracting or repelling them. Mathematically, electric field is denoted by E. The electric field at a point P at a distance r from charge q is equal to 1 over 4 pi epsilon naught q divided by r square into r unit vector, where q is the charge and r is the distance of separation between the charge q and point P. Electric potential. An electric potential is the amount of work needed to move a unit of positive charge from a reference point to a specific point inside the electric field without producing an acceleration. Let's consider the work done on this test charge. By moving this test charge from initial position I to a final position F inside an electric field. The work done by moving this charge from initial position to final position F will be given as W is equal to F dot ds. And according to electrostatics, we know that the electrostatic force between two charges is given by F is equal to Q naught E, where Q naught is the test charge and E is the electric field. Now the work done on this test charge will be equal to W is equal to Q naught integral I to F E dot ds. Dividing both sides of the equation by test charge Q naught, we will get W by Q naught. And this W by Q is the potential difference. So the potential V is equal to I to F E dot ds. This minus sign is due to the fact that the work must be done against the electric field in moving the charges apart.
Yeah. Okay. So this is just a potential definition which is explained in this particular animation. Okay. So this diagram is also showing the definition of potential only. If we are having a charged particle, then if we want to move that charged particle from infinity to a particular point in the electric field, then the work done by moving a charge from infinity to other point is equal to the electric potential at that particular final point. Okay. So after discussing about the electric field and electric potential, we need to see what is meant by electrical resistance. So whenever we are discussing about the current, electric current, for the current to flow, there must be some medium. The medium is generally a conductor. Every conductor will offer certain amount of resistance for the current flow. That amount of resistance, that is opposition, offered by the conductor to the flow of current is known as a electrical resistance. In other words, electrical resistance is a property that opposes the flow of electric current in a conductor. So the greater the resistance, the more difficult it is for the current to pass, because resistance means opposition. If the greater is the opposition, then current may be very difficult to pass through the conductor. The resistance is measured in ohms and it depends on factors such as conductor material, length, cross-sectional area, etc. So resistance is useful in controlling the current, because if there is no resistance, the current may become infinity. So that's why the resistance is the most important parameter in the electrical engineering. See, these are the different types of resistors we can come across in our practice. That is a fixed resistor or color coded resistor. Next, thick film type LDR, light dependent resistor. Next, thin film type potentiometer, trimming pot, surface mount, thermistor, rheostat. Rheostat is a wire wound resistor and varistor, etc. Okay. And coming to the next parameter, that is in the elements of electrical engineering, inductance is the next parameter. So what is inductance? Whenever we are taking any piece of wire, whenever we are taking any piece of wire, and just that is just wound in the terms of in the type of a spiral or helical shape in this manner, then automatically what happens is, whenever the current is passed through this particular wire, whenever the current is passed through this particular wire, okay, so it will, what happens is, it will behave as a magnetic field source. That means the thing is, the whenever any piece of wire is wound into a coil, it will form a inductance, which is the property of opposing any change in the current. So inductor is a passive electronic component that stores energy in the form of magnetic field. We know the thumb rule. So according to thumb rule, if the current carrying conductor is placed, uh, if the if we hold the current carrying conductor with our right hand thumb, so such that the thumb is flowing in the thumb is in the direction of current flow, and the remaining fingers encircling the conductor. Okay. So in that case, what happens is, here, for example, if this is the current carrying conductor, so let us assume that this conductor is carrying current from down to up. If we hold like this, such that the thumb indicates the current flow direction and the remaining fingers indicate the amount of magnetic field direction, that is magnetic field will be developed, that is known as a thumb rule. So the inductor will follow the thumb rule and develops the magnetic field. So it will store the energy in the form of a magnetic field. And different types of terms which are involved in the inductors are, first is the inductor, inductance, self-inductance, and unit of inductance is the Henry. Okay. Here, the figure shows the different types of inductors which are in practice. Okay. So all these are inductors. Inductor is simply a coil. Next topic is capacitor. A capacitor is a passive two-terminal electrical component used to store energy in an electric field. Capacitor is a energy storage device which is made up of two terminals or two electrodes. Okay, the two electrodes are separated by an insulator called dielectric. The dielectric can be made of paper, plastic, mica, ceramic, glass, etc. Okay, some capacitors are now called electrolytic, in which the dielectric is aluminum foil conductor coated with oxide layer. Okay, so this figure shows that different types of capacitors, glass type capacitors, tantalum, film type, aluminum type, mica type, air type, ceramic, tuning, paper, supercapacitor, niobium capacitor, tremor, etc. All these are types of capacitors. Next, we will see what is an electric circuit. An electric circuit is a closed loop system allowing the current flow, is a foundational concept in electrical engineering and electronics. Essential components of circuit include different types of elements such as voltage sources, current sources, conductors, uh, resistors, inductors, capacitors, etc. Circuits can be classified as series circuits and parallel circuits. In the series circuits, the components are connected in single path, and in the parallel circuit, the components are connected in multiple paths. Okay, see this. If we consider one battery that is source of electrical energy, that an electrical energy, if it is connected to a bulb with the help of some switch, the control switch and conductors, so whenever the switch is on, the bulb will glow. Okay, so then what happens is the circuit will be closed. The circuit will be closed. So here, this in this particular slide, it is shown that a series circuit and a parallel circuit. In the series circuit, the one end of the element is connected to the starting end of the second element. In the parallel, the two elements end points are connected together and that is connected across the battery source. This is also an example for the series RLC circuit: battery, inductor, resistor, capacitor, and all these four are contributing to the electric circuit. And this is the power flow which is normally coming to the our houses. See, the power is generated at the power generating stations such as hydroelectric power or a thermal power plant or nuclear power or any other power generation plant. So the consumers need not be at the nearer places to the power station. That's why the power has to be transported over long distances through the overhead lines. So when the power is carried through the overhead lines, the voltage will be should be very high because in order to avoid the losses. So the voltage of the power or voltage of the supply can be changed by means of a transformers at various levels. Okay. So after transporting the power over large distances, the it will be supplied to the various type of consumers like domestic consumers, industrial consumers, commercial consumers, etc. Okay. Now we will see the Kirchhoff laws. There are two types of Kirchhoff laws: Kirchhoff current law and Kirchhoff voltage law. Kirchhoff current law states that the sum of all currents entering into a junction in an electric circuit is equal to the sum of all currents flowing out of the junction. For example, if we consider this particular second figure, in the second figure there is a junction. Okay, at that junction, 8 amperes current is flowing downwards and 5 amperes coming to the left and 3 amperes coming to the going to the right. So here 8 is equal to 5 plus 3. Incoming current is equal to outgoing currents. Okay, this is the basic principle of Kirchhoff current law. Kirchhoff current law can also be stated as the algebraic sum of the currents at a particular junction is equal to 0. Here, these animations will show you the different types of circuits: parallel circuit, series circuit, okay, like this. Now, Kirchhoff voltage law is states that the sum of the voltage differences around any closed path in a circuit must be is equal to 0. Whenever there is a loop, for example, in this particular diagram, this is the battery, this is resistance 1, this is resistance 2. The battery voltage is the source voltage, and the two resistor voltages are the 1 volt and 3 volts respectively. So if the supply is 4 volts, that is plus, and remaining two are the drops, minus 1, minus 3. Plus 4 minus 1 minus 3 is equal to 0. So this is the Kirchhoff voltage law. And we are having two types of circuits: parallel circuits and series circuits. This particular diagram shows the parallel circuit in which the current I is flowing divided as a three parts: I1, I2, I3. Okay, and this is the series circuit. In this, the current I is flowing through the R1, R2, R3. The same current is flowing. Here, this is the difference between the series circuit and parallel circuit. Okay, so the Kirchhoff current law and Kirchhoff voltage law can be better illustrated by means of this particular diagrams. In the first diagram, the uh, currents C, A, B, D are coming at the junction, and E and F are the going out of junction. So A, B, C, D, A plus B plus C plus D is equal to E plus F. Similarly, in the second diagram, the source is A, remaining all are drops. So A is the source, B is, if we follow any convention, sign convention, we need to consider. So whenever the if we can evaluate, or if we take the loop as in this manner, okay. So whenever the current is flowing out of the positive terminal, then we can call it as a rise, voltage rise, okay. So here, if you see, all in all these elements, the current is flowing out of the positive terminal. That's why all are voltage rises. That's why A plus B plus C plus D plus E plus F is equal to 0. This, in the first diagram, the A B C D E F are the currents. In the second diagram, the A B C D E F are the voltages. Okay. So this is the general introduction of the particular KCL and KVL. In what learned we had learned about we started with the basic charges. In the summary, what we had learned is we had learned about the basic atomic structure. From the basic atomic structure, we can conclude that there are three types of charges. There are three types of particles, charged particles. Okay, out of them, two are having a charges and one is not having any charge. And after that, how to separate the electrons from their basic atoms, that we had seen. That is known as the ionization. After electrons are separated, we had seen what is meant by current. Current is the flow of electrons through a medium per unit time. What is the direction of current? We had already seen. And a battery as a source of current, and we had seen the electric flux lines. There are flux lines which are similar to the magnetic flux in the case of electric field. So flux lines will be starting from positive charges and ending at the negative charges. The direction of the electric field is given by the electric flux lines. Next, we had seen Coulomb's law. Whenever the two charges are separated by a small distance, then the force of attraction or repulsion between the two charges will be directly proportional to the product of charges and is inversely proportional to the distance square. Here, like charges repel, unlike charges attract. So, electric field intensity. Electric field intensity is inside an electric field at a particular point. If you take any charge, the force acting on that charge is known as a electric field intensity at that charge. Next, we had seen what is meant by electric potential. Electric potential at a point in an electric field is defined as the work done in unit charge. Okay, as the work done per unit charge in bringing that unit charge from infinity to the that particular place inside a electric field. We had seen some animation. Okay, after that we had seen what are the basic elements. The basic elements of the electricity are resistance, inductance, capacitance. Okay, next we had seen what is meant by electric circuit. Electric circuit is a closed loop system allowing electric current flow, is a fundamental concept in electrical engineering. We had seen different types of that is series circuits, parallel circuits. Later, we had seen the power flow from the generation plant to the different types of consumers. After that, we had seen KCL and KVL. Okay, so this is the summary. Thank you. If you are having any doubts, you can just mail me at my email ID. Thank you.